I need to talk to you about even functions. An even function is any function where f of the opposite of x equals f of x. An odd function is any function where f of the opposite of x simplifies to the opposite of f of x. And to test to see if a function is even or odd, you simply evaluate the function at the opposite of x and see how it compares to f of x. So if our function is x squared plus 6, and I need to determine if that's even or odd, or maybe neither, I'm going to evaluate f of the opposite of x. Negative x squared, or the opposite of x squared, is going to end up being x squared plus 6, which you'll notice is exactly the same thing that we started with. So we have demonstrated that f of negative x is equal to f of x, so this function is even. Alright, for function g of x, which is defined as 7x cubed minus x. If I want to determine if that function is even, odd, or neither, I'm going to plug in a negative x. Being careful about signs. And then simplifying that. If you multiply negative x times itself 3 times, you're going to get the opposite of x cubed. So that first term becomes negative x cubed. Negative times negative, negative times negative is a positive x there at the second term. And then that, if we factor out a minus 1, that would give us positive 7x cubed minus x. And what's in the parentheses there is the function g of x that we started with. So there's our evidence that g of negative x is equal to the opposite of g of x, and this function is odd. Notice there, before we simplified that, each sign, all the signs changed. For a function to be the opposite, every single sign on every single term has to have changed. Okay, function h of x is defined as x to the 5th power plus 1. If I'm going to determine if this function is even, odd, or neither, I'm going to substitute the opposite of x in the equation and then simplify. Now when you compare that to what we had to start with, only the first term has changed sign. The plus 1 is still plus 1. So this doesn't fit either the definition for an even function or an odd function. This one is neither even nor odd. Function f of x equal x squared plus 6 we've already determined is an even function, and I've got the graph of that function there below the equation. And I wanted to point out that that function has symmetry in the y-axis. Every even function will have symmetry in the y-axis. So if you're looking at a graph of the function, it's very easy to pick out whether or not the function is even. Graphs of odd functions have symmetry in the origin, and 7x cubed minus x is an example of an odd function. And the graph of that function is there. Symmetry in the origin is harder to see, at least I think it is. But basically what that means is any point you have on this curve, so whatever the x and y coordinates are of that point, there has to be a point with the opposite x. So whatever x and y you've got, there has to be a point on the curve with the opposite x and the opposite y coordinates. So when that's the case, then you have symmetry in the origin. All odd functions have symmetry in the origin.